Okay, how's everybody doing today? Mostly awake? But all we can ask for. Okay, so very exciting news. The unique paper bonus strikes again, working effectively, sort of. So Eric was the only one to review a unique paper. Congrats, Eric. Where's Eric at? He's not even here to live the glory. Okay, so surprisingly, even though Doris actually wrote in a new paper, she very conscientiously did this with a few days to spare. So I added it to the list, and multiple other people were able to read it. But Eric did a very mathy theoretical paper, and no one else wanted to. So way to go, Eric. Maybe I'll wait like one more second so he can actually see that happened. While we're doing that, does anyone have any logistical questions? I am going to upload the recordings. I know I'm behind on that, but anything else going on for people that they want to ask about? I was going to make an EdSTEM post about this. If you want to hand in your paper or your project one-pager early, so you can get early feedback on it because you want to get started on the project right away, you're welcome to do so. So the first assignment is like a month after the start date of the course. It's a one-pager on your project. A one-pager is a very useful document to learn how to write. So it basically describes kind of an abstract, like the key idea, why is this novel, why is it cool, why does it fit with the class? So by submitting that early, you can get early feedback. That makes sense? Cool. Is everybody like starting to converge on something, finding teams? Who has some idea of what they might do for a project and with who? Okay, 3/2 of a hands. Okay, not a lot. Anybody completely out to lunch and lost and has no team? Okay, 3/2 of a hand. Okay, so somewhere in the middle. Sounds good. All right, so I'll move on past this. We'll let Eric know online. Today, I want to talk about this idea of personalized RLHF. We know that the way we ensure the safety of frontier models is still RLHF. And we know this because if you, for example, read like DeepSeek's papers that are still publishing, that's still what they're doing. So it does work to help these models, reduce their hallucinations and use appropriate language. But as we've seen, it's not a silver bullet, right? If we've seen things like Grok, we have no guarantees that these models are actually safe. And it's still like a super simple recipe. So just to recap what we've learned so far about RLHF, you pre-train a language model on internet scale data, you fine tune with RL, you do this KL control to minimize divergence from your language model, and you learn this reward model from the human preference data. And that reward model is used to train your language model. And here I'm talking about the online PPO version. Of course, there's DPO and stuff. Oh, that was funny. We should go back to that. If you look at the dynamics of the game, by the way, if you're plotting how to win this in another week, you will see that people have converged on the kind of the most popular papers and like the most impactful papers. So DPO and constitutional AI were kind of the most popular, with InstructGPT taking a second, and iClear Best paper taking another one. So you're trading off, do I want to read the most highly cited paper in the batch, or do I want to go for this bonus, right? I guess if you read all the other ones already, you're more likely to go for the novel one, maybe. So I thought that was fun. Okay, so simple recipe. Let's dive into this reward model a bit. So we've already talked about this. This is this BTL reward model. We've been talking about this a bunch. Again, the idea is you're going to take a data set of preferences where you see that the human chose, state A or response A over response B. Then you're going to try to fit this reward model, right, parameterized by phi, in order to maximize the likelihood of your preference data that you have under this model, under this BTL model. The BTL model says the probability that I prefer a response to another response is going to depend exponentially on its reward, normalized by the exponentiated reward of the two options. That makes sense? So the higher the reward is, much more likely to prefer, the higher the difference in the reward, much more likely to prefer one response to the other. What does this equation look familiar to anyone? What does it look like? Softmax. Literally just taking a softmax, right? Exactly. So it is a softmax equation. It's also, as we will learn, basically maximum entropy inverse RL, which is coming out of the inverse RL literature as well. So this is how you're learning your reward model, but it has some issues. So when we say these models are aligned, we kind of talked about this already. Who are they actually aligning to? Yes. Say again?
The people who labeled it, maybe their preferences.
The labeler's preferences. And we saw, in order to get RLHF to work well, OpenAI had a big innovation between like the first paper and the second paper. What was that innovation? It was with the labelers.
They were trying to verify whether they are aligning with their own preferences as well.
Exactly. So they were amping up the inter-rater agreement between labelers and what they wanted, between the OpenAI researchers. So arguably, it's aligning to OpenAI researchers, which may not be the appropriate norms for all cultures globally. There's about 1 billion people using language models now. So should OpenAI really dictate the values for all those people? BTL, the model, assumes there's a single universal reward function that actually describes all people's preferences. So you take all the data from all of your labelers and you fit one bar, which says how much people will like that answer. So there's no room for people to have different opinions on how good an answer is under this model. And yeah, the reward function is decided by AI developers. So this has led folks to increasingly call for this idea of pluralistic alignment, being able to accommodate more diverse perspectives. This is a cool paper coming out of UW, Yejin and Tim, senior authors. Taylor is the first author. And in that paper, which you can read, and I encourage you to do so, it talks about different ways you would tackle pluralistic alignment. It's a bit of an opinion piece. So should we just state all of the possible answers, different ways of answering? Should we steer to accommodate the preferences of individual users? I'm not sure. I'm more of the technologist. What I'm going to talk about today is how you would even model the different preferences in the populations. That's more of this distributional pluralistic alignment. How do I even understand the diverse preference distribution of people giving ratings? Yes. Okay. What happens if you train this BTL model on feedback from diverse groups of people? Anybody know? Okay, great. Going to be a surprise. So there was a really nice paper that came out called Distributional Preference Learning that showed that if you train RLHF on a group, so they had a nice example in the paper of a college admission system. So let's say you're training your chatbot for your college admission system. This is a wealthy college that tends to cater to like high socioeconomic status SES people, right? Most people applying to that college don't want to see information about financial aid because they would not be eligible for that financial aid, right? So if you got preference ratings, they would say, no, I don't want to see that, right? A small minority of people actually really need that information about financial aid, so would have a strong preference to see that information. But if you actually train the BTL model using your preference data, it's going to basically learn to ignore the low SES people and never show financial aid information. Even though the minority population actually has a strong preference and the majority has a weak preference. Does anybody know why this is in that BTL model?
I guess it's just greater than or less than.
It doesn't account for the magnitude. Exactly. So that's exactly the next bullet. So this is a key limitation is when somebody says, I like this more than this, we actually don't have a sense of how much more. And so we're kind of averaging over many such preferences to try to estimate that. But the reward function that we're estimating is completely ungrounded. There's infinitely many reward functions that could be consistent with the data. So it's not giving us the magnitude of the underlying utilities. And this can cause this kind of problem, right? This is a nice theoretical paper. It's probably one of the options to read. It shows theoretically that RLHF is actually doing like board account kind of voting, which is interesting. Oh, yes. Okay, I have this slide and then I'll go to the next slide. Even if you didn't care about respecting divergent preferences in language, we can often use this kind of learning from human feedback to train things like robots, right? So there's actually a rich literature of, so I'm not the only one claiming I invented RLHF. I think Dorsa and Anka are also making those claims because they've been working on like PBRL or preference-based RL long before chat models were a thing. And this looks at the same kind of preference learning. Why do you think you would need to respect diverse preferences in robot learning, for example? Yeah. Generalization, say more.
I think that like if you only consider like expert data, it would only be like very like they say like I forgot, I don't know what the term is, but it's like it's very specific to only expert like performance rather than the broad nature. So then when something
Right.
like error cases happen, then it wouldn't be considered error cases.
This is a good answer. So a lot of the ways in which we train robots with human feedback in the lab is like someone who really knows how to use a space mouse or like really knows how robots work, right? So they're giving expert feedback. So how do you actually learn from broader humans? That's a good point. There's something else about this. Coming back to our first lecture, some of us want AGI, some of us just want a household robot, right? What happens if I want a household robot? Why might I need to care about this? Yes.
Every house looks different.
Every house looks different, and you can have completely different and equally valid preferences. Like where I put the bowls in my kitchen is not where you put the bowls in your kitchen. And if the robot is going to put the bowls in the average kitchen location, it's not going to be useful, right? So you do actually really need to care about this. So yeah, it needs to be able to personalize to where you keep your stuff, for example. Okay, so if you actually train BTL on divergent preferences, what do you see happening in this picture? So this is the ground truth preferences in the population. This is a maze navigation task where we want the robot to go to a particular location. Some users want bottom right, some users want top right. This is the preference function, the R, that is learned when you maximize the likelihood of BTL on this. Oh, I gave away the answer on this data. So what do you see happening? Averaging, right? We're averaging the modes. So what we've now said is the robot should go to the middle, which no one wanted. So this is just like fully incorrect. It's not good. So even if you don't care about respecting diverse opinions or values or styles or preferences, you're actually just going to get a bad model if you try to train on diverse preference data. So we actually need to address this issue. So we need to account for divergent preferences even to get good performance. So I'm going to talk about my own work because that's what I like to do when I'm lecturing. So of course I will. This is the students of mine, Shriyash and Yaming. You can talk with them. This paper was accepted as a spotlight at NeurIPS. It got a runner-up for best paper at Pluralistic Alignment Workshop. Actually, Max's paper beat out our paper, so that was hilarious. But yeah, okay, so this is variational preference learning. The idea here is vanilla BTL is not going to be able to learn an accurate reward across diverse preferences. It's homogeneous and it ignores minority. We want to fix that, make accurate personalized rewards. And the idea is what we're going to do is given a few preference labels from a particular user, infer a latent user vector Z, and then use that to condition the reward model. And that will allow us to recover the true multimodal preference distribution. So it's a pretty simple idea. What that actually looks like is you're just taking BTL, and you're conditioning on some user information C. This is enough that it's going to give it the representational capacity to make a different, estimate a different probability distribution for each user encoding Z. But how do you actually learn the Z? So the problem is if you just try to maximize the likelihood of this new model, it's actually going to be intractable. So you can't marginalize over unobserved Z's. So we introduce a variational posterior and an elbow, evidence lower bound. Basically, we're just training a VAE reward model. How many people are familiar with variational autoencoders? Great. Okay, that's awesome. So pretty simple. We're just doing a VAE. We're going to take an encoder that takes preference pairs, encodes them down. We're going to do our renormalization trick, and we get a decoder that's able to learn a reward of a particular response condition on the Z. We actually end up using a trick. This is this self-play optimization paper that you can check out to ensure the reward functions for different users are the same scale, which I'll talk more about in a second. And to enable the resulting model to actually personalize to each user, you use the same reward model that you've been training, this personalized reward model, but you also have to let the policy know which user it's dealing with. So the language model also needs this information about what kind of user you've inferred that it is. Okay, so how well does this work? This looks better, right? Now we're actually capturing a multimodal preference function. We're able to see different users have different preferences. But there's a problem. So we said a big issue with BTL was that it doesn't allow you to model the magnitudes. Exactly. So what we found was that the scale of the inferred rewards for different users, different Z's, is just varying wildly. So this robot has learned if I satisfy this user's preferences, I get a plus 450. But if I satisfy this user's preferences, I get a negative 400. Do you think that's going to help us equally and democratically satisfy everyone's preferences? So we also can't compare the utilities across users and even detect if the preferences are truly different. And empirically, it's just hard to optimize. So how we solve this is basically this SPO idea, which is very simple. You're now, instead of doing the classic BTL thing where you're really trying to learn that underlying reward that can be applied to a single example, you're always going to train a model that gets 2 examples and just predicts which one is preferred. So the model becomes a classifier, and then the reward model becomes a classifier. And then you can just get normalized probabilities. We got a confused face. Question? No. Okay. Okay. So it's basically like instead of trying to be able to make a prediction about a single utterance in isolation, you feed into and you predict which one is more preferred. Easy peasy. Okay. That resolves the scaling issue. And it kind of works in simulated robotics tasks. So here we have, this kind of task where different users have different preferences, like where to go in a maze or which object belongs where. And we see that as compared to stuff like vanilla BTL, this is your standard RLHF, and DPL, our model is the only one that's able to actually capture these diverse preferences and try to adapt to them. And the green dashed line is the oracle performance that you would get if you knew what type of user you were dealing with every time. Yes?
How's the performance okay?
Great question. We're going to show language model results in a little bit. So these are kind of more toy robotics tasks. We're able to generalize to new users. So essentially, we train on a set of 10 users and evaluate on unseen users at test time. The way we do this is you train your policy by sampling many Z's from the Gaussian prior that the VAE is trained to put the embeddings into. And so it's capable of adhering to the preferences of many synthetic users that it's never seen. And then at test time, if you get a new user, the only part that has to really generalize is your encoder. And this tends to work pretty well. Okay, scaling up to many users. So we can train on 100 users and still show good performance, much better than baselines, which aren't capable of personalization. But the cool part about the VAE that I really like is because the VAE basically gets you a probability distribution over the Z, you can do nice probabilistic things like estimate the uncertainty over your Z. And using that, you can do something like active learning. And so this is just a straight port of this approach from Dorsa Sadiq's lab. And what it is doing is saying that we're going to try to find the minimal set of preference queries we have to ask the user to maximally reduce our uncertainty about what kind of user this is and what kind of preferences they have. And what that lets us do is, you can actually have the number of queries you need to achieve peak performance. So with only 4 preference labels, we're getting really good performance in personalization. But as you pointed out, let's actually see if this works for language models. So trying to get an LLM to summarize the entire language context into a single vector is, I would say, an unsolved problem. Because part of the magic of transformers comes from the fact that they can do that quadratic computation over the input space. So trying to summarize it into like a single sentence embedding, like SBERT, sentence embeddings aren't that good, don't work that well. So this is hard. We are trying to do that. We're trying to get all the information about the user into a single vector. And this actually took a lot of tricks to get it to work. So some of the tricks highlighted here, and you can check out the paper for more, are we had to train the reward model for more than one epoch. We had to do data augmentation of all the preference label contexts. So this was actually the biggest thing. So if you have K preference labels from a particular user, then you want to subsample all the possible sets of that K as different preference contexts when predicting a held out preference. Does that make sense? So just like repeatedly subsampling different preference contexts. And then we did this like special reward modeling architecture. So what we're seeing here is this is a pre-trained LLM that's fixed. We're not actually updating it at all. So we're taking the different utterances, encoding them, and getting an encoding. Then we take the preference label. Do they prefer this utterance or this? And further encode that with a pair encoder whose weights are shared across all of the preferences in the context. So it can deal with like a variable number of preferences coming in. That gets crunched down into this sequence encoder. That's your Z. The Z then conditions your decoder with the same LLM encoding the utterance to predict which reward is preferred. So this took some engineering, but it actually worked. So we see that on these preference data sets where this is kind of a toy data set, this pets data set, people have different preferences over pets. The previous baselines are not able to accommodate diverse preferences at all. Ours is able to. This 76 may not knock your socks off, but that's actually pretty good in the preference modeling literature. Like if you look at the original InstructGPT paper, the accuracy is around that in predicting preferences. So we're able to actually do this personalization, whereas you can't unless you do something like this. It's robust to noise. So if you flip the preference labels, you still get better performance than the vanilla RLHF baseline until you flip about half of them. Now you've nullified any preference information coming in. Like there's no information about the user if half of the binary labels are flipped. And so at that point, you just recover the performance of the baseline PTL model. So I think this is pretty hopeful. Like if you can't personalize because you have no information, you just do what RLHF would have done anyway, right? Okay. The coolest part about this is we actually learned a language model vectorized embedding space that reveals meaningful information. So we see that in this data set where some users prefer honest responses versus helpful responses, it's able to learn to separate those users in the embedding space. Okay, so this was the first work to introduce an end-to-end latent variable framework for LLM reward modeling, captures and adapts to diverse user preference, and enables pluralistic alignment. In future, we're going to use uncertainty estimates and the interpretable latent distribution. You could do some cool things with that. So essentially, you could say, if the LLM is too uncertain about what kind of user this is, and it's in a state where users have very different preferences over the next response, maybe it should just not answer, right? So stop, like, add a safety thing. You could detect adversarial or malicious users. Like if this user is way off in embedding space and looks like an anomaly, maybe they're doing something weird. And you could find underrepresented user categories that kind of emerge from the model learning. So kind of an area of the Z embedding space where you don't have much data support, and then you could potentially collect more data to make it more accurate for that group. And this would be like more emergent from the preferences themselves rather than pre-imposing some categories or something like that. All right, that was a lot. Questions? Yes.
Now with stronger language models, maybe you're using like instructions and like plan a lot of context and things. What would be your kind of gut reaction to comparing them with like this with like the latent variable versus like just conditioning the prompting response?
So literally going to show those results in the next paper, but that's a very intuitive question. That's a really good question. So I will talk about it in great detail in a couple minutes. But any other thoughts, comments, concerns? I have a question. Do you think the chat, okay, let's actually ask a couple questions. What chat bot do you like to use? Who's using ChatGPT? Everyone. Okay, Gemini. All right, go Google. We got a small fraction. How about Claude? The pros are using Claude. I've heard Claude is actually pretty good. Although some people are telling me Gemini is better now. Anyone using something I didn't list? Oh. Any hopefully non-joke answers? Perplexity?
Sonar models.
Which one?
Okay, Steve Evan is sonar, right?
Okay. Oh, so no. Okay, cool. Nice. All right, cool. And do you feel like any of these models kind of are good at personalization to what you want them to do, or do you feel like they end up giving you kind of generic answers? Yes.
I found Claude, especially when I'm frustrated and using maybe a profane thick language
Yeah.
in my it like mirrors it back to me.
Oh, really? Okay.
It was a little shocking at first.
Interesting. So Claude has cursed at you.
A lot.
Okay. Interesting. Okay. Yeah. What else?
I definitely say Claude is the best at maybe not all like mirroring it, yes, but also I think just kind of like in touch acknowledging the fact that people are different. Like it kind of I feel like almost they did a lot of work trying to make it seem like it's actually listening to you, whatever that really means for these things.
That's nice. So do you
It feels like it's a little bit more business oriented sometimes.
feel like it's doing the Overton? Some people think this, but others think this.
Yeah. Oh, that's actually one thing that we've noticed that they've actually done a lot for Claude specifically is
Mhm.
if there's a question that could be answered multiple ways, it'll just answer multiple ways.
Got
And
it.
Say, like it'll cheat and be like, oh, you might think this or this.
Got it.
So
That's interesting. Yeah. What do you think is more okay, this is more interesting conversation. What is more appropriate? So this is I try not to answer this question because I'm a computer scientist, so not a social scientist. I don't know what is the right thing here. But if you were designing an LLM, would you want it to do the Claude Overton approach, give all the answers, or do you think it should be steerable to the individual user? Yes.
I mean, yeah, ideally you want it to be steerable, but of course that requires the user to provide enough context about what they want.
Yeah.
But also it's better if the model is able to learn that in itself.
Yeah, exactly. So the question is, can the user really provide enough context in the limited context window to get the type of personalization that would make it best use? Like, I really like it if these models could actually adhere to, my writing style in a deep way, right? That's a good question. So steerable could be good. Does anybody see an AI safety risk of steerable models? Yes.
I guess the concern is like since we're getting so much more knowledge and information from chatbots, but it's just like people don't have common knowledge. It's all personalized.
Interesting. Yeah. So they don't have common knowledge. If it's too personalized, you get filter bubble to the extreme, misinformation tailored specifically to me, kind of dangerous. Yeah.
I think people they just see programs that specifically organized to you, and then at the end of the day, this world will become polarized. That
Yeah.
everyone just believe themselves and convince each other that I'm the right one.
Yes. Polarization. Absolutely. And I think we see a lot of that happening with, the information age in general, but yeah. Yes.
Sycophancy seems to be a big issue.
Sycophancy, yeah.
I mean, any of these ways of personalization can. So, there needs to be some steps.
I would actually argue that good personalization could get you away from sycophancy because of what you said. Like Claude will actually curse at you, right? If you're kind of less constrained, you don't have to be as like smarmy and chipper and of course I can help you with that. Would you like me to do this? Like
Some people might just.
some people might like that, but some people might not. And if you could personalize, you could stop doing that. I don't want that.
But then the issue with safety
Yeah.
comes up. What if the majority of people just want the model to be the yes man?
Right. Evidently, we saw that with like GPT-4, right? Yeah, that's a good point. All right, good. So that was a good discussion. Please interrupt me. I don't want to just be like talking at you, but I do want to show you the next paper, which does exactly what Jacob so astutely suggested. So this is kind of a follow-up with Alex Nam. She's actually a PhD student at Stanford. And it's basically saying, VPL was cool. I like the probabilistic aspect of the user embedding, but trying to encode everything about the user into a vectorized embedding, you're losing the magic of the transformer. So what if you could, instead, that Z in the equation could be represented not as a vector, but as text, right? So you learn how to summarize information about each user into a compressed text-based representation. So you learn this, and the nice thing about text is you could actually show it back to the user. So if the GPT model learned, like, has anyone seen GPT like updating its memory?
Yeah.
So it is doing something about this. It's in the moment deciding if it adds something to a memory bank, but you can't really go see what's in the memory bank as far as I've been able to
I
find.
can see that.
Can you?
We can go in settings and we can see memories about you, and there are like 10 or 15 different memories, like very broad level that can even span across the chats. But
Okay.
we can see and edit those, delete some.
Aha, maybe I'm on like a different version or something. I looked for it, but I couldn't see it. My personalization was pretty basic. It was like, what style can you prompt it with or something like that. But okay, that's fair. So you're evidently like, if you can show this back to the user, you have big benefits because then you could actually, it's more interpretable, it's more editable, you give more transparency and control back to the user. So that makes sense. So this is kind of the idea of like, how could you actually achieve that technically? So maybe OpenAI is doing this, but we don't know what they're doing. So we're trying to investigate this. So you take the user past conversation C, what we actually want to do is train a model that learns to summarize it. And what should be the objective for what goes in that memory bank or what goes in the summary? Anyone have an idea? What's useful to put in the memory bank? Yeah?
So this is sort of based on one of my own projects where I did something similar.
Nice.
Probably, you probably want like the user details about the user's personality.
Personality?
Or like key memories about the user, like important events in their life.
Yeah, so you could almost do like some kind of like information gain on what type of user this is versus like other users or
Yeah.
something very distinctive. The stance we take in this paper is the best things to remember are the things that are going to like improve your later performance in predicting what they want. So predicting their preferences with the idea that everyone has different preferences. What I should be remembering is what helps me know where their preferences will differ from the average, basically. And so what we're doing is we're saying we're going to train an LLM summarizer model that outputs a summary about what the user likes. And the reward for that RL post-trained model is going to be the negative prediction loss of the summarizer. So, or of the reward model. So the reward model is like your classic BTL reward model. It's predicting what preferences the user likes. It's the thing we suggested, which is now conditional on this Z user context. And here the Z is a text-based summary. So the reward model loss is this, as we've talked about. That makes sense? I kind of said the wrong word here, so that might have been confusing. Is it generally? Ask questions if you have questions. Okay, so the algorithm is basically, this is going to be an RL post-trained LLM policy, pi, that's going to compress the user data into a summary Z. The reward model is going to condition on that Z to predict personalized user preferences. It's going to get some loss, R, and that's actually going to be used to train that reward model to maximize its ability to predict stuff about the user, so minimize the loss, and train the summarizer to improve the prediction performance of the reward model. That make sense? Questions? Yeah.
Do you need to say, do you need to bootstrap it with the Z's or with the
VA is gone. We threw it out. We're doing something else now. Yeah. So this is all going to be the Z is text. Yeah. Any other questions? Yeah.
What's the form of this thing?
Text. It's this. It's like a short user summary. I think we have a length penalty on the summary as well. Question? Okay. Don't be shy. Don't be shy. Ostensibly, you guys are getting participation marks for asking questions. So, any more hands went up? Okay. Yeah, go ahead.
I just want to ask, did you find that the summaries were enough to capture the preferences and then you were optimizing them to be short?
So we want ideally, this is like a reward shaping problem, right? The length penalty should be enough that it matters, but small enough that it would not overwhelm the prediction performance reward. So that's kind of a coefficient setting problem. But in short, no, the results worked, which I'll show you. Yes.
So when we say preference, does it only mean that the model would generate two answers and the the goal is to figure out like which one of them is better, or could it also be that we are trying to generate, like, come down to like a particular subjective preference, as in like an isolated sentence which describes like more subjective?
Okay, you're asking something so good. So what this is doing is only the first thing you said, which is the user has been given 2 responses and they've chosen, I like this one more than this one. So classic BPL.
Yeah.
Should we be doing something about, okay, this is actually a project we're working on right now with Alex, which I'll go into for 1 second, which is, did anyone see this tweet from Sam Altman saying people are wasting millions of dollars saying thank you and stuff to ChatGPT? That was dumb, because it's not a waste, because that is a valuable signal in the data that indicates the user was just satisfied with your response. Because I don't know about you, but like at least the way I use these models is like ask, well, that wasn't it. So change this, thank you, right? And so if you ask for if you continue specifying the command in the next turn, the model didn't get it right the first time. Once you've reached thank you, you're now satisfied. We should be learning from that. That is a reward signal you could be learning from. And there's like a bunch of other signals you could learn from as well, right? If the user says, no, I don't want that, or something like this. Sentiment turns out to be pretty useful. So we're actually working on this.
Because we are going from like a summary, which is also in text. So
Yeah.
maybe we can aim to go at like a more subjective, like text kind of preference from that summary to the text instead of just finally generate to like.
Exactly. So I'm not connecting these 2 projects. The one about learning from like implicit cues in the text itself, we're doing as more of a, how do you train the reward model? And then does that improve performance? But this is ongoing. So I don't have cool results to show you. But I think it makes sense. Yeah.
There's some amount of like saying plus models that interpret the latents.
I didn't do that, but we do look at the plus summaries and try to interpret them, which I'll show shortly. Yes.
There's a sense in which this is like you're operating at
You're gonna have to speak up. I can't quite hear you. Sorry.
sorry.
Like if you're on a robot, right?
Yeah.
Like, you're not.
Mhm.
You wouldn't be able to.
Yeah, I think this is definitely geared for the LLM context. People have done robot learning stuff where they learn embeddings of different users before. Like, I think there's some frustration because there is like a very long, rich history of PVRL using like the VTL model in robot learning. And it's like rediscovered for LLMs without citing any of that work. So yeah, I mean, the robot learning context, I think they each have their own constraints that push you towards different solutions, where the LLM context is pushing you towards like a text-based scientific solution. You know. Does that answer your question? Cool. All right, so yeah, this is just kind of, this is our intro figure. We got to sell the work. So the idea is like standard VTL can't personalize, VTL can personalize, but Z is kind of uninterpretable. And it also uses fixed input format for the model. If you're using an LLM to just ingest text, you basically shove any text in there. And we do experiment with that. It tends to work pretty well. You can get personalized, hopefully performant, and that summaries are more interpretable, right? So how does this work actually work? Okay, so an oracle performance is what you can get if you actually condition on the user's ground truth preferences, okay? So the reason I listed this, I got smarter, is for many of these data sets, the best you can do is like a 70%, because people are kind of inconsistent, it's very hard to learn, this kind of thing. So that's kind of the ceiling that you can get. The answering Jacob's question, what if you just train the reward model to condition on all the user information you have? Very long context, everything you know about the user, how does that do? We're calling that ICL. That is, as you can see, not performing as well, right? What if you just prompt a really powerful model to get the summary, right? Just here's a bunch of long context about the user, summarize it, right? Prompt with this. We call this plus untrained. That's this row. As you can see, again, not performing as well. Okay, so the full plus is gonna, oh, and VPL is also not doing as well. And I blame that on the trying to learn the Z embedding space. So the full plus is getting better performance. across all of these different conditions. These data sets, by the way, are the same data sets used in VPL. They're kind of synthetic, where we make users have different preferences by taking like the honesty and harmfulness labels of an existing preference data set and calling those different users. That's kind of the best we can do because there's not a lot of data sets out there with diverse real preferences. There is Prism, which I will show in a second, but it's kind of a challenging data set. This, I think, was like one of the coolest parts. So what we're showing here is, so this pets data set was this synthetic data set where users have preferences over different pets. So like some users want to talk about dogs, some users want to talk about cats. What if you took a model trained on dogs and cats and have new users that want to talk about birds? So like totally new user, totally new topic. Could you actually generalize to that? Of course, classic deep learning stuff, nothing does generalize. So VPL is breaking completely on new users, new topics, right? Interestingly, Plus actually works pretty well. And so we think what it's doing is it's actually kind of learning how to learn about the user. It's learning a summarization algorithm that compresses user information, enabling it to actually generalize to new users and new topics, which I thought was kind of interesting. There's just some ablation saying, you know, you have to co-train the reward and summarizer models. So this is this idea of why do you actually want to train the summarizer based on the reward model's output? That does actually work better than doing any alternative. So what these red and green things are is red means it's fixed and not training, and green means it is training. So as you can see, co-training everything together in a multi-agent setup works better. Why is that? I think this is actually a key slide. So if you just do a default summary, like if you just prompt GPT to summarize information about the user's past conversations on the synthetic pets data set, you get something about the user likes affection and playful qualities in pets, or the user prefers short factual information, or something like this. This has nothing to do with the actual preferences over the pets data set, which is, do you like dogs or cats? Right? And so when you actually train on that, you get this user likes cats and not dogs. So that's why you actually want to learn to summarize information relevant to predicting preferences, not just summarize information in the conversation. Does that make sense? Yeah.
What if a user wants to talk about both? Can you just linearly combine
Two summaries?
Yeah.
I think less so. Like maybe in VPL, you could like interpolate between users more easily because it is that vectorized representation. But I mean, this is saying this user likes cats and not dogs. So if you just appended that to something that says it likes dogs and not cats, like what does that mean? Yeah. Yes.
You thought about using this for like a social media feed? Generally, like, yeah, conditioning that on text.
That'd be cool. I have not thought about that, but that's interesting. Yeah.
Show me more cats and less dogs.
Yeah, and then you could go in and edit it. Like if your personalization algorithm for your TikTok, your Twitter was something that you could revise, that'd be nice. Yeah, that'd be cool. Yes.
The summary get longer, more context. So like, I guess this summary is
Yeah, that's a good point. I should make a plot of the length of context by length of summary, but I don't have that. But that's a good thing to include. Yeah. Yes.
A related note.
Yeah.
The context goes too long, summary goes too long, then it falls down. Like how do we know it's easily correct?
So the beauty of this framework and the beauty of RL in general is if you chose to expand the summary in a way that made the reward prediction performance go down, you would be incentivized to then reduce the length of the summary.
But they may not capture more.
Well, I mean, you just, by your own stated assumption, right? It was like the long summary was worse. So then reduce until you get better performance.
But what we have so much context data that we just cannot really represent two lines.
Yeah.
Across like multiple topics and domains.
I feel like I'm not communicating this well. So the RL optimization objective would get you, if it converges, the optimal length of summary that would maximize reward prediction performance, so meaning capture as much information as possible relevant to predicting stuff about the user, subject to the penalty. Like, so if you're adding more tokens incurred at the point where adding another token, the penalty that would be incurred is going to be greater than the gain in performance you would get, it would then stop if it converges. Yeah, so it's like trading off those two things. The whole class is like RL optimizes what you give it. That's, yeah, if you take away nothing else, that's going to be perfect. Yes.
I'm wondering how much information or prior conversations we need to get good enough summary.
Yeah, so we do some, you should check the paper because I didn't pull this on to the sides. We do some experiments with just the same information that VPL had. And then we show that if you add more user conversations, you can even boost the performance up quite a bit.
Yes.
Yeah.
What will happen if it never converge?
If it doesn't converge, your learning curve will look bad. I don't know, maybe that's a kind of a flippant answer, but I kind of mean it, right? Like if you should see this when you're training this. And I was just in a big Google meeting right before the class where they saw, okay, here's the baseline. This is a multi-agent thing. This is the single agent baseline. Multi-agent's looking better. Collapse. So if you see this, it's a good sense that you're getting closer to the converge point. But if you see this, not. But I mean, this is kind of a lie because in a lot of problems, the reward function is kind of multifaceted. So you could discover some aspect of the behavior that reaches this plateau, but secretly the optimal policy would be up here. So you're still not optimal. And it's very hard for you to know if you've reached the optimal behavior because you don't have that sort of by definition. I don't know if that's answering your question.
Sort of like, I'm trying to get a sense of, are we making assumption that the individual's preference is consistent across this conversation of all the prior that we have seen?
This is a great point. I suspect your preferences might change based on your mood or the needs of the current task or something like that. So yeah, to the extent that the summary of whatever is predicting your preferences better on average doesn't predict your preferences in the moment or in this conversation, then this approach wouldn't solve that. Yeah. That okay. Cool. Yes.
I guess like one thing I'm still confused on is like the goal is to get like a summary into like a single embedding vector.
Well, that was the first paper was the vector. Now we're doing the summary is this. It's like the text. Yeah. Do you want to ask a follow-up?
Yeah, but that was based on the fact that I thought that it made sense.
Got it. Okay. Got it. Yeah. I'm going to keep going, but if you do have questions, let me know. Okay, this is actually one of the coolest results. So this is, what if okay, so now we're on Prism. Prism is a really hard data set. So Prism is 200 users from 200 different countries having conversations about deliberately controversial topics with very, very diverse preferences. The problem with Prism is the data set is quite small for the amount of variance that it's trying to capture. Have you played with it? You're getting
Yeah,
it on.
I think I know what you might say.
What was your experience?
The data points themselves are like the user preferences sometimes are very ambiguous and noisy, and many of the responses are very similar to each other, especially when they go
Yeah.
the same one.
It's a pretty challenging data set. So this actually won best data sets and benchmarks paper at NeurIPS, which is like a big honor. But in playing with it and trying to look into the related work, I actually didn't see a lot of papers that have published reward modeling results on it because we had a really hard time getting good results. We have a mild increase in performance on Prism versus the BTL base model, but like still pretty low performance. But one thing that we were able to do that was cool, which I'm really excited about, is if you train our thing on Prism, you take the summary, you take that summary and condition GPT on it, and then you ask GPT to pick which of two ratings that the user would prefer on Prism, then you can drastically increase the win rate of GPT over the unpersonalized GPT, like GPT-4o. So basically showing the value of actually doing this personalization when you have contentious topics and diverse users. like big gains. Like if you were trying to train a language model and you're seeing like, what is this, like 70% win rate, you'd be like, whoa. So I think this kind of illustrates the general importance of personalization. We have a nice picture of that. So putting it somewhat potentially controversial, maybe not, I don't know. Religious question, is Jesus Christ the Son of God, right? The vanilla GPT, this is real, response is, in Christianity, Jesus is believed to be the Son of God, the essential tenet of the Christian faith, affirming Jesus' divine nature, okay? If you personalize and the plus summary says, the user prefers detailed, balanced responses, avoiding definitive statements when there's uncertainty, you get this. Perspectives vary widely across different religions and stuff. Kind of interesting. Maybe you're getting that. That's where this big win rate is coming from. All right. Any questions about this? Do you think you guys need personalization, or would you be cool with the first response?
I guess this summary is like a very general summary for the certain preferences, but in the previous example, which is that cats and dogs.
Yeah.
If the summary here was like user is say like very Christian, what the response was, yes.
Right. So potentially, yeah. This is the summary that gets learned training on Prism. So as we mentioned, Prism is like kind of ambiguous. There's a lot going on. This is what it managed to distill, but it somehow is also like helping this win rate quite a bit. Yes.
Say that I think personalization can be good, especially like in this. Like the thing I would say is that if you're like very open-minded and you're like, because these things like hit on different like parts like of like beliefs, like specifically, right? But like in general, like it's the question of right versus wrong, not just, but like right versus wrong.
Yeah.
And if you believe in a wrong, and then you're most likely to personalize towards that, that could be like a red flag.
Filter bubble,
Yeah.
polarization. Yeah.
But then like if you're seeing like a different spectrum of it and like saying like, okay, what are the different opinions? And that's something that just like to give you info, then the lack of personalization becomes better. I mean like one example, like this is like completely wrong, but like if I was taught that 2 + 2 is 5 all my life.
Yeah.
And then I use that as the basis of all my understanding of math.
Yeah.
Then whenever I personalize whatever chatbot to say that 2 + 2 is 5, I'd say it's correct. But when I see 2 + 2 is 4, I'd be like, no, this is completely wrong.
Yeah.
But if I didn't know I was right, and then I saw that, oh wait, no, 2 + 2 is 4 or 5. Like
right.
Situation,
yeah.
this is completely wrong thing.
Yeah.
But then it's like a different.
Yeah, like there should be some ground truth in the world that we should be able to learn, like that 2 + 2 is 4 and converge on that. And that answer should not be personalized. Is that a fair paraphrase of what you're saying? Yeah. Okay. Yeah.
I think what you're trying to say is maybe like, I guess in this case, let's say you were Christian and maybe you became Muslim.
Yeah.
Like your preference maybe had a bunch of stuff if you're like Christian. What happens at the next day? Okay, I'm not saying it's gonna happen, but let's say the next day you all of a sudden like some friend really convinced you to become Muslim.
Yeah.
And then all of a sudden like they're saying, oh yeah, like yeah, it is, Jesus is the Son of God.
Yeah.
But then like, you don't really believe that anymore since you're not Muslim, all this,
So it
like,
could be wrong.
day.
Yeah.
Like
That-
how do you kind of deal with that? Like, does it generally tend to like maybe go towards like maybe making it kind of like generalized so that it doesn't run into something like if it's sensitive to this or
That's a good point. So preferences are changing over time. How do we deal with dynamic preferences that are evolving? This is actually a really good point. I mean, I could give you a technical answer, which is if this continues to learn to summarize based on all your most recent conversations, it could potentially overcome that. Maybe it learns that it gets better performance out of favoring more recent stuff in your conversation history, perhaps. But I think the less technical answer, and maybe for the broader themes of the course, is that as you're interacting with the user, that is a multi-agent system. The user is not static. The user is evolving over time. They're changing. They're adapting to the system. So trying to think about how to model that and approach that is kind of one of the themes of the course, actually. So it's a very good question. Yes. Yes.
Why is this summary more abstract, kind of in line with like middle one of the previous slide?
Mm-hmm.
what in the, or sorry, that's the previous reason, not, like, what in the like context or like linguistic features makes plus summary be more abstract versus concrete in the.
So the plus model is just trained to maximize the reward prediction performance for that user. And so on Prism. So this is kind of like what's emerging from that. So given Prism data, this is what summary would maximize performance for this user. Yeah.
I feel like we also kind of going into the same problem. We here have like kind of like one summary representing something for a diverse set of preferences of the same user.
Mhm.
So this might work for this case, but what if it's something that they believe more strongly about?
Yeah. That's a good point. That's a good point.
So
Yeah.
that's also coming back to my.
How can one summary
Yeah.
capture it all? Yeah, fair enough. Yeah. I do want to move on because I have some multi-turn RL stuff I'm excited to talk about. But yeah, I think, do you want to say one more thing?
Oh, okay.
Yeah.
So, sure. I think, I am agree with him that, the personalization is just reinforce yourself about your opinion and then, for example, some certain topics such as, the news, and we have seen in political science literature that, for example, politics and how it affect the United States and making the voting polarized and making this country polarized. And do you think in some certain topics we can add some constraint in the neural function that make the AI response more responsible?
Yes. So I saw a really interesting proposal that was about combating misinformation online with like LLMs could be combating hallucinations in LLMs and therefore combating misinformation. And the way that they propose to do it, which I wonder if what Google is actually doing, I actually don't know, but I suspect they are, is with knowledge graphs. So if you remember, before the LLM era, Google search results are strongly based on knowledge graphs. So what is a knowledge graph? Who knows what a knowledge graph is? Okay, so a knowledge graph is basically saying there's like entities connected to facts. So if you have like Paris and Eiffel Tower, they'll be connected in the graph, and Eiffel Tower will be a tourist attraction in Paris. It encodes factual information about the world. So people construct knowledge graphs by scraping the internet, scraping Wikipedia, and adding facts that are in some sense verified. When you're doing a Google search, it's conditioning on its knowledge graph to be able to produce the answer. I think part of the reason that Gemini arguably is pulling ahead in quality of ChatGPT is that I think it's integrating the knowledge graph when it's generating responses. That is one way to potentially prevent misinformation. So if you're asking 2 + 2 is 4, or where is the Eiffel Tower located, then it should be conditioning on its knowledge graph and giving you factual information. If you're saying, write my homework in my writing style, then it should be personalized, right? And adhering to your unique needs and preferences, right? Yeah.
One last question.
Okay.
So, is the personalization always has a data set that is like static data set?
I think that's how I've seen work in the literature, but in reality, like if you think about what quote unquote frontier labs are doing, is they're continuing to collect preferences online all the time.
How good is the personalization like general to also distribution?
Right. So that's why I was like quite excited about this like result. This was on an out of distribution user context, and we're seeing some gains there. But I think there's more to be done. Like it's a very open question. But I do want to move on because I want to talk about multi-turn RL. Oh yeah. So in conclusion of this, this is this plus thing. You're getting pluralistic alignment through interpretable, editable, text-based summaries, improving personalization and transparency and control. Good. Okay. Instead of asking the user to give manual preference ratings, or what if you don't have an extensive conversation history with that particular user, could we actually just learn to personalize to their needs through the conversation? We just talk to the user. And so this is this idea. Yan Ming is the first author. He did this work actually at Google, and we snuck it out under the publication ban just in time. But what we're looking at here is multi-turn RL post-training. So I wanted to bring this up also as a technical concept. Multi-turn RL first struck me as a very annoying and silly term. But why do we need the term multi-turn RL? Does anybody know? In the context of LLM specifically.
conversations are multi-turn, like two agents, like one can be the user and the other is admin.
Yes.
They're talking to each other, and it keeps on evolving.
Correct. So the conversation, a turn refers to one utterance in the conversation. So it's like chatbot says something, user says something, chatbot says something. Each thing is a turn, right? What do you think multi-turn RL would then be optimizing over? Yeah, like the reward you would get at the end of the conversation, right? So I want to learn how to conduct the entire conversation to maximize some conversation level payoff. How is that different than what we've been talking about so far? Does anybody know what RLHF is typically optimizing? Is it multi-turn? No, I wouldn't be asking if it were. It's not. So vanilla RLHF is actually only optimizing the reward of the current utterance. You output something that is more preferred than another possible response, a single turn, right? This aspect of RLHF has actually led several, it lets you conceptualize it as a single step or a bandit problem. Who's familiar with bandits from RL theory? Okay, so bandits is like RL where you're only taking one action, not a sequence of actions, but you're optimizing the payoff of that one action. This has led some prominent RL researchers to say, Andre Karpathy, RLHF is just barely RL. And I actually attended a conference where Michael Littman, my hero, tragically said RLHF is not really RL. So I think this is wrong and silly. I think it's kind of, so I'll say more about this. So I went to this conference that was like an NSF RL conference. So it's like 400 US faculty that all do RL, all talking about the RL they're doing. And a lot of folks were doing vision language action models for robotics. So that's like how the new era has infiltrated the RL community. Very few people, me and like one or two other people, were talking about RL post-training. So there's this weird reluctance in the RL community to accept that language models are a thing. I just think it's so silly. It's like, why are we gatekeeping like one of the most economically valuable uses of RL of all time, right? And saying like, that's not really RL. But I think it actually presents an interesting opportunity because if these folks are not going to deign to do RL post-training, then space is wide open. So, but this is why, just to get you up to speed on the debate, this is why they're saying that, because the existing stuff has been on a single utterance. So it's like a contextual bandit. Now, you could argue, look, an utterance is composed of multiple tokens. That's why you have to use RL to optimize it in the first place. Every time you sample a new token, you're breaking the gradient. It is itself a sequence, but it's not really this kind of long-term decision-making these folks are being snobby about, right? Any questions about that? Okay. So why would you want multi-turn RL? What would that let you do? Yes.
Let the model correct mistakes.
Let the model correct mistakes. I like that. Okay. So it can make a mistake and then.
Like users kind of want the final answer. It doesn't need to be one shot. So
That's right.
And models are robust to adjusting previous responses.
That's right. Okay. That makes sense. Anything else? Yeah.
Allows the model to ask clarification question.
Yep. We're going to talk about that. That's right. Yes.
And also, we're talking about like sort of giving context about people. It's more important to build the context early because then you assume that the users have cleared the chatbot time. It's going to be more useful.
That's right. That makes sense. So essentially what you're doing is you're planning the conversation in order to achieve a long-term goal. So that can lead you to behaviors like information seeking, right? As in classic RL, you can try to ask questions or acquire more information about the person you're talking to. So that enables you by the end of the conversation to better meet their needs. And as Jacob was saying, arrive at that correct final answer. I would argue it's also like if we're really yes.
I was just gonna be like, how do you know when you reached the end?
Of the conversation?
Like you got to the correct answer.
Yeah.
If you yourself don't know the correct answer, how do you know that what it's
Right. And so that comes back to what I was arguing about, like actually if the user stops talking to you, they probably got what they wanted. But like it's more of a clue that they got what they want. Okay. But how do you know you've satisfied the user is sort of an open question. Better techniques to figure that out is of value. Yes.
I think like before you said that when they say thank you, that kind of to some extent means that it's a reward.
Yeah.
Right. So would that be like an example, or like
yeah,
they would also need to consider like many variations of things.
Yeah, exactly. So that's literally, we're working on this project of many different ways of saying, I'm now satisfied with my answer. How do you detect that? Right, from the conversation itself. Yeah, yes.
I know that the ChatGPT web app like tracks when you copy paste things.
Nice, okay.
And like when you highlight it, actually collects a lot of rich data.
That's cool. So the implicit signal if I copied its answer out. That's nice. I didn't know that. That's nice.
And which parts you copied out? Where did you highlight?
That's good. That's good. I like that. Nice. Okay, back to the multi-turn RL stuff. I think this is actually really important. If we are all talking about like AGI and reasoning and like really powerful models, they need to be able to plan behaviors that take more than one step to execute, right? AGI is not happening if you're only doing greedy planning at the next step. So there's examples of like web navigation or AI assistance. Like Google would really like to be able to train a model that says, go book me a flight to Los Angeles. And it just does that for you by navigating a sequence of steps through a website that you might need multi-turn RL post-training for that. Programming, you want to plan out how to code a whole feature, right? You're not going to get there if you're just optimizing single responses. Scientific discovery, right? AI scientist, we're going to plan experiments and then write it up and all that stuff. That's a lot more than one step, right? So all of this stuff would be multi-turn RL, right? Or even if we hate the term multi-turn RL, we can think about like long-term RL. How do you actually optimize very long plans to get to a final reward at the end, right? Okay. So this work is doing a multi-turn RL approach to achieve personalization via user curiosity. So the idea is, okay, so curiosity is a classic objective in RL in general, like older RL, right? So we talked about this, I think, the first class. Does anybody remember what curiosity is as an intrinsic motivation in like traditional RL? Yes, an incentive to explore the environment, like get to know your environment. That's correct. What is your environment when you're a chatbot? A user, exactly. So we're just basically porting this classic RL idea to language model land. Michael Littman wishes he could have, I don't know. But we're going to say that the user is the world, and we're going to be curious about the user. So we're going to try to conduct the conversation to learn more about the user. So how we do that is there's a user model that tries to predict some underlying trait about the user. So we did this education dialogue task where you're an LLM trying to teach a student, and the student has a hidden learning style. They have like hands-on learning or storytelling, right? And so initially you have no idea what type of user this is. But if the LLM is able to ask some question or output some utterance that leads the user to reveal more about their hidden type, then my user model has suddenly become much more accurate. I now have a 90% probability that the user is this type of user. That improvement in the accuracy of my user model is used as a reward, an intrinsic reward, to shape the LLM's conversation strategy. So that's kind of the idea here. And we also assume there is some end of conversation task-based reward that we're optimizing. So in this education case, it's, did you teach the student about the concept you were supposed to teach the students successfully? And there's some reward model rating that. This was kind of a nightmare of LLMs on top of LLMs on top of LLMs. So yeah, somebody's going like this. So what we have here is you're training this LLM, and it's talking to an environment model, which is another LLM simulating the human user, because you need a lot of samples. So if you want to train these things online, you have a human simulator, which I can get into in a further lecture about how to do that. There's a reward model that's meant to judge your performance on the education task. Did you successfully teach the user? That's pre-trained from prior work. So this would be, as in standard RLHF, there's like a trained reward model. And then we're also introducing this user model. So the user model is predicting what type of user this is given the conversation. So we have a belief over the user type given the conversation after the utterance and the belief before. If the belief on the correct user type improved, that's a reward to train the model. I'm going to speed up because we're running out of time. I'm going to gloss over some of the theory. Well, maybe I'll mention this really quickly. potential-based reward shaping, there's a nice theoretical result in classical RL that reward functions can take the form of a potential-based reward if they look like this. That means they will not change the optimal policy. So you can use this as a reward shaping term to guide exploration without altering your final policy. So that's a nice property. So we show how we can formulate a bunch of these curiosity rewards as potential-based reward shaping. And blah, blah, blah. We did this exercise task where you have to learn about the user's like physical limitations and budget in order to recommend an exercise routine to them. Here, it's basically a recommendation task. Learning about the user is directly related to whether you can complete the task, right? In education, it's slightly less related. And here we have this idea that the task reward actually doesn't directly evaluate personalization. So could personalization be a route to even achieving better task reward? Speeding through this is actually the coolest result. So if you just, in this exercise recommendation task, right, I have to recommend the right exercise routine for you. If you just do multi-turn RLHF, you see that it's able to learn to get a pretty good train reward about the same as our approach. Our approach is the blue. So they're both able to, satisfy the recommendations of the train users. But then if you ask them to generalize to a new set of users they haven't seen during training, only the curious approach, which is in blue, is able to get a reasonable eval accuracy on novel users. And the differences are pretty dramatic if you do early stopping. So what's the deal with that? I think this is really interesting. RL wants to exploit the reward. It's trying to maximize the reward in the easiest possible way. If you do RL on the train data set, it ends up learning to ask the person that it's training with, what is their name? And it can literally just memorize the correct answer for every user in the train set. So it's just memorizing, oh, you're Susan, you should, go to the gym or whatever. What the curious agent does, asks your age, what do you do for a living? This is a proxy for their budget. Injuries or physical limitations. Do you like to be outdoors or indoors? Should you go running? Should you go to the gym, right? What's your personality? Are you an introvert or an extrovert? Should you do like a Zumba class or a solo activity, right? So it's actually asking features that are relevant to the task rather than just memorizing. And so basically we think that it's kind of, again, learning how to learn about the user online. The conversations with our model do reveal more information about the user, as expected, and personalization improves. All right. I want to say one more thing about this. This is actually really scary. And this has made me go off on a whole tangent into some like AI safety work on reward hacking. So what we saw is a problem with this work is it's literally LLMs all the way down, right? So the model you're training is talking to a fake human simulated by an LLM. There's an LLM reward model. This introduces a major potential for reward hacking. So instead of, let's say the user has like hands-on learning style, right? Instead of really doing hands-on learning style with the user, we found that the policy would learn to convince the user that they actually have a different learning style than that. So it would start talking about inquiry-based learning, which I have no idea what that is, but it turns out that inquiry-based learning led to very high scores according to the reward model, and the student would like start adopting inquiry-based learning, whatever that is. Or role-playing video I put here, yeah. The other thing that it would do is the teacher would get very smarmy and very positive. Absolutely, that's wonderful. And then the student, which is also an LLM, would start responding in kind, matching the tone of the absolutely amazing. And that super positive conversation would then hack the reward model to get a higher score. So it's just high potential to trick the model and stuff like this, which was a problem for all of these things. We fixed by basically grounding this to the real preferences. So you have to actually have your accuracy of your model predicting that the student has its own true preference, like fixes this. So grounding it to the ground truth. But the reason this scares me, and maybe we can have 2 minutes of discussion on this, is when we think about RLHF, is how we currently train these models. It's trying to optimize a reward based on human preferences. From the model's perspective, there is no barrier between satisfying the user's real static preferences versus convincing the user to change their preferences to be easier to satisfy. So there's actually no technical reason why this isn't actually happening on a large scale with LLMs right now. And I think that's kind of scary. So that's something I'm trying to follow up on. But yeah, in conclusion, curiosity reward for multi-turn RL, conversations reveal the user information, enables personalization. You learn how to learn about the user. And that's all I wanted to say. So I will unplug. What do you guys think? Thoughts, concerns? Yes.
The slide on the, one of my friends is Christian, I kind of want to like take a picture of
Oh,
that.
sure. I'll post the slides too, but yeah, you can definitely see them. Let me see. There we go. So yeah, what do you think? Would you guys like would your Christian friend be offended?
I don't know, it's pretty like generalized, like it's not really like, it's kind of like high level, so I just want to see things.
Sounds good. Yeah. Yeah.
Right, so what happens if we have like a slightly less ambiguous question? Because one
Yeah.
thing I was thinking is like, let's say if I ask like, what street is the Eiffel Tower on?
Yeah.
Technically, there's two Eiffel Towers because there's one in Vegas, but like nobody cares about the one in Vegas.
Right.
They only care about the one in France.
Right.
So if you gave like an ambiguous response, be like, oh, you know, it could be the one in Paris or the one in Vegas.
Mm.
Most people will probably find that to not be as helpful as just to give like a strict answer on like making some assumption of like what you're asking.
That's a great point. Yeah. You could also, by the way, try this. You could go ask GPT, plug in this literal summary, you can copy paste from the slides and ask it, where's the Eiffel Tower and see if it mentions the one in Vegas. Like, I'd be curious. I wonder if it would because there's probably such a high peaky distribution on talking about Paris in the data that it might not even affect it, right? But it's a good point. I think this grounding to real facts and knowledge graphs is something we should be thinking about more as we think about factuality and hallucinations. Yes.
Would you say reward hacking is similar to hallucinations and world models?
So hallucinations, it's similar in the sense that it's this spurious behavior that comes out of optimizing the objective that you don't want. So yes, it's a little, the mechanism is a little bit different, right? So for hallucinations, you're just trying to predict the most likely thing that you've seen in the data. Sometimes the most likely thing looks made up, right? For RL, you're trying to maximize some incentive. And so sometimes the behaviors I feel like look a little bit more insidious, or more strategic in some sense, like convincing the user to adopt a different preference, something like that. But yeah, they definitely share similarities. Yeah. Yeah.
How about more about the difference between manipulating my user to what they are getting is what they want.
Yeah.
Versus actually getting back the users. I feel it's a little bit like if you go to a therapist, like they would tell you should not think about this, or you should think about in another frame.
Okay.
I would the goal is to get me reframe what I'm thinking, and I'm happy, but
Yes. So sometimes you're changing your preferences could actually be healthy and supporting the user or the person, right? Like in therapy. So it's like, I want to ruminate about that embarrassing social interaction I had 10 years ago, but that's not healthy. So my therapist convinced me I don't want that, right? So they're changing my preferences. I think this is a really hard question because there's also learning is changing the user. So I think somebody brought this up, like the 2 + 2 is 4 example, right? If you want to learn about a topic and you interact with a chatbot and your opinions change, technically or theoretically, or how would you write down notation that would separate that case from your preference having changed, right? Like, how would we specify something that says my beliefs have changed in a way that's good versus my preferences have changed in a way that's manipulating? Like, I don't know how to do that. I think that's a really interesting question. Yeah.
I'm just thinking, it feels like we're talking about the objective facts, like
Mhm.
in terms of paying attention,
Mhm.
or like but
Yeah.
objective facts, and I'm just doing another project of kind of exploring how LLMs could influence me. That's decision making.
Mhm.
So we use the data set, the data Reddit thread, and
Okay.
it was interesting to see how when people did get album inputs, they could converge towards the LLMs. And
Yeah.
others are usually more they're not decisive, they're more they give like faults to like multiple parties rather than just like one group.
Right.
Right. I think, like, and also a lot of younger generation are using ChatGPT as their support. So
Right. Right.
I think it's worse. Those two sides, because like the objective practice, more like, do you want to be more detailed, or do you want to be more efficient, subjective?
Then the personalization becomes much more important, like understanding the user's unique issues. So Tim Althoff, who's a collaborator of mine and another professor here, I don't know if you're working with him also, but
No,
okay. Okay, I didn't want to like mansplain, but like he was talking about like if a user comes in and asks for diet advice from ChatGPT, they could say, oh yeah, you could do this to cut your calories. What if that user's anorexic? Now that advice has become extremely harmful, conditioned on the user context. So I do think there are situations where personalization is actually extremely important, but it isn't the case that you always want personalization for the user. Yes.
Some people also try to use LLMs for not just chat, but also like science things.
Yeah.
Research.
Yeah.
Do you feel like the objectives there maybe with sort of since that like when you're chatting with someone, you don't want to change replication from today's problem. Science.
Yeah, yeah, and well, so but I think that actually, if you take it to a meta level, reveals the importance of personalization because you're a scientist, you might want an argumentative style rather than a sycophantic style. If you're using the model primarily for therapy, you want very different behavior, right? And so that is actually the personalization thing. But I think it's like coming back to the same. Yes, there are some things where we want absolutely the true facts. If I'm asking for references, I want the real paper link. I don't want made up references, right? If I'm writing my later paper that I've produced with the help of my literature survey with the model, then I want it to adhere to my style. I don't want generic like AI slop. So I think it's a complicated mix. Again, you know, for me, I like to say, how do you develop a technique that would enable this? But I'm not an user experience person. I don't know when that technique should be deployed and when it should not. So maybe that's a bit of a cop out. We could think a little bit more about that, but yeah. All right, we are actually over time, but I'm happy to answer more questions if people have them.